and welcome to Dr. G's Technique of the Week, Precalculus Edition.
Today we want to use linear functions to model some real-life situations and to make some predictions based on data. So we're going to be considering these data points, which give a person's age here on the horizontal axis versus a person's blood pressure here on the vertical axis. So for example, we see that we have one person in this data set who is 17 years old and has blood pressure 110. We have another person in this data set who is 70 years old with blood pressure 142. Now, we don't have blood pressure data for every single person who exists, or even for a single person from every single age. For example, we might have someone who is 48 years old, and we don't have a data point for a 48-year-old person, but we might want to predict what we would expect their blood pressure to be, and that could be something really useful to know so that we can have an idea of when someone's blood pressure is normal, when it's not. So, we'd like to be able to approximate what we would expect, and these are sort of lined up in a pretty nice linear way here. So we could sort of eyeball it and just look at a 48 years old, go up and look on the y-axis and say, okay, well, we'd expect that to be between 125 and 130 for their blood pressure. But we'd like to have a more precise way of measuring that. So one thing that we could do is try to approximate this data with actually one individual straight line. And one thing that we could do is just connect a couple of points in it in a way that looks pretty close to what it should be. For example, we could connect our two outside points in this data set here. And then if we wanted to find the equation of that line, we could then use that equation to predict some expected value for blood pressure based on age for any age person. And since we have 2 points, we can just use point-slope form for the equation of a line to find that equation. So if our 2 points are 70, 142, and 17, 110, our slope, just using our slope formula, will be 142 minus 110, so a difference in y values, or a rise, over 70 minus 17, our difference in x values, or our run. So this will be 32 over 53, approximately. And then we can just use point-slope form to write an equation for this line. I'll use the point 70, 142 for this, but we can use any point that we'd like. So y minus 142 equal to 32 53rds times x minus 70, and this will give us an equation for this line. So take a moment, using this equation for the line, try and come up with an approximate value for the blood pressure y given an age of 48 years. All right, let's go through that solution together. So we can just plug in 48 years in for x. And then we just need to simplify everything and solve for y. So we'll have y equal to 32 53rds times negative 22 plus 142, and that'll give us approximately 129 for our expected blood pressure for a 48-year-old person. But we'd like to have a more mathematical and exact way of picking this line, better than, oh, this kind of looks right. And the way that we traditionally do that is with a least squares regression. We pick our straight line through our data to minimize the sum of all of the vertical distances between our data points and our approximate line, our regression line. So by vertical distance, I mean if I draw a vertical line from a point to this line that I'm drawing through the data, and then I take the square of all of those distances and add them up, I want that total to be as small as possible. And there's lots and lots of different software that we can use to do that. In order to find a linear least squares regression line for a set of data using Google Sheets, you can just go to Google Docs and open up a new spreadsheet and type in any of the points you want in 2 columns. So here is our same data with our ages in the first column and the corresponding blood pressure in the right column. So the first thing that we need to do is graph these in a scatter plot. And we can do that by highlighting them, going to Insert, and selecting Chart from the drop-down menu. Under Chart Type, we can select the scatter chart, and now we see just those points graphed here with age on the x-axis and blood pressure on the y-axis. Now to get that linear least squares regression line, you can go to Customize here at the top right, and then open Series. Under Series, there are a few options, and one of them is Trend Line. If you check the Trend Line box, it'll put that linear least squares regression line plotted on the graph for you. So there's our good linear approximation that is going to be minimizing the vertical distance, the sum of squares of vertical distances from each of these points to that line. And if you want to get the equation from Google Sheets for that line, under Label, you can say Use Equation, and it'll tell us that this graph is approximately y equal to 0.511x plus 104. So now that we have this equation, give it a shot and see if you can use this equation to find the predicted blood pressure for someone who is 48 years old. Now it's time for you to get some practice with these new ideas. See you next time on Dr. G's Technique of the Week.